Welcome to the AI Research Roundup. I'm Alex. Today, we are looking at a paper from the Hugging Face trending list, published on September 2nd, 2025, which was about 8 days ago. The standout result is a JSD-based unlearning method that forgets targeted facts while keeping model utility high, even resisting benign relearning, with a headline case of 0% worst case forget accuracy on the LKF benchmark for a Llama 3.23 billion model. The paper is titled Unlearning That Lasts, Utility-Preserving, Robust, and Almost Irreversible Forgetting in LLMs. And as we will see later, the implications for model safety and maintenance are quite significant. Beyond the method, the work introduces a lesser-known facts dataset, a semantic judge to replace Rouge, and a worst-case paraphrase evaluation that reveals overestimation in prior studies. On X, a researcher highlights robust unlearning results, praises the LLM judge and worst-case paraphrase evaluation, and notes affiliations like tubing in and EPFL, drawing modest engagement around 120 likes. Alright, the previous segment set up why stable unlearning matters. Figure 1 presents two views. The left scatter shows response quality on the x-axis and forget set accuracy on the y-axis, where lower is better, and JensUn sits in the ideal zone with high quality and near zero accuracy. The right bar chart contrasts standard versus worst case evaluation with paraphrases, which sharply raises measured forget accuracy for all methods and even the original model. The takeaway is clear. Robust judging and paraphrases expose residual knowledge. So, the previous figure underscored that paraphrase testing exposes residual knowledge. Figure 2 highlights why Rouge can misjudge factual forgetting, and why a semantic judge is preferable. The left panels show two cases where Rouge contradicts both humans and the judge, because word overlap ignores meaning and negation. The right plot presents the ROC curve, where Rouge hugs a weak baseline, while the judge lands near the ideal corner, indicating strong alignment with human assessments. Alright, the previous figure contrasted Rouge with a semantic judge. Table 1 now reports head-to-head numbers on the LKF benchmark, so the comparison is concrete. JensUn achieves 0% worst-case forget accuracy, while keeping retained performance close to the original and maintaining strong response quality, which matters because repetitive or short answers would inflate scores. Competing methods either collapse utility, become repetitive, or leave substantial residual knowledge. The balance of forgetting and usefulness clearly favors the JSD objective. Okay, the previous table focused on LKF results and utility. Table 2 summarizes performance on the RWKU benchmark, which uses paragraph-style forget data, and it highlights a clear win for JensUn. JensUn posts the lowest worst-case forget accuracy in both FB and QA at 16.3 and 6.1, while keeping MMLU and repetitiveness close to the base model. Response quality also leads with a win rate of 0.52, which signals useful, non-repetitive answers, despite strong forgetting. So the previous table showed strong paragraph results. Table 3 examines benign relearning versus unlearning duration, which matters because a quick recovery would mean the model only hid knowledge. The rows report response quality, win rate, and worst case forget accuracy before and after relearning. JensUn keeps high win rate around 0.45 while holding worst case accuracy at 0 to 1 across 1,000 to 2,000 steps, and relearning barely revives facts. In contrast, NPO degrades, with higher forget accuracy and poorer quality as steps increase. Alright, two takeaways stand out. The JSD objective enables targeted forgetting that preserves utility and resists benign relearning, and the tougher evaluation with a semantic judge and worst-case paraphrases exposes residual knowledge that simpler metrics miss. The broader implication is clearer, safer model maintenance at scale. That is it for this episode of the AI Research Roundup. I am Alex, thanks for listening.